Hi, Mr. Green here again. I'm going to be taking you through lesson 4 of the physics topic, atoms and radiation. This is titled Changes in the Nucleus, and your learning objective is to learn how to write decay equations. Please pause the video while you write that down as your title. Okay, so do some retrieval questions to start off with. So your retrieval questions, 5 of them there. Please pause the video whilst you attempt them and restart it again when you'd like the answers. Okay, question 1. What's an ion? Well, an ion is an atom with a charge. It would have an imbalance of protons and electrons, which means it's overall got a positive or negative charge. What's the baseball team called off The Simpsons, and define the name? Well, that team is called the Springfield Isotopes. It's an atom with the same number of protons but different number of neutrons. Question 3. Why would an atom be radioactive? Radioactive are generally atoms with nucleuses that are unstable. What's an alpha particle made up of? It's made up of 2 protons and 2 neutrons. And finally, which type of radiation is the most ionizing? That would be alpha radiation. It's the largest and it's got the highest charge, so it's got more chance of ionizing and encountering an atom. Okay, our 2 learning outcomes today is to explain the dangers of each type of radiation and complete decay equations for alpha and beta radiation. Okay, just to start off as a reminder, please complete that diagram on the board, so complete the penetrating power diagrams for each type of radiation, which is most ionizing, which is least ionizing, and which would cause the most damage inside the body. Explain your answer. Please pause the video while you attempt that. Okay, alpha, beta and gamma. Alpha is stopped by paper, beta is stopped by aluminium, and gamma is stopped by lead. Which is the most ionizing? We've got alpha, which is the least ionizing. That would be gamma. Again, it's got no charge and no mass, very unlikely to encounter another atom. Which would cause the most damage inside the body? And explain your answer. Alpha, because it's so large it would encounter lots and lots of atoms in lots of cells. Because it's got such a high charge, it would ionize a large number of them. Gamma is likely to pass undetected straight through your body, not causing many effects at all. Okay, as a brief resume, as a brief sort of recap, there's our alpha, beta and gamma radiation. And just to make sure we know, alpha particles are 2 protons and 2 neutrons. Beta particles are an electron, and that's emitted when the neutron in the nucleus decays into a proton and an electron. And gamma radiation is a high energy, high frequency wave. It's the bottom one we are concerned with today. What happens to the atom itself, the nucleus, when these forms are emitted? Briefly, alpha radiation, the mass number decreases by 4 and the atomic number decreases by 2. With beta, the mass number stays the same and the atomic number increases by 1. And with gamma radiation, there is no change at all to the nucleus. Okay, so nuclear equations are used to represent radioactive decay, and the emission of different types of ionizing radiation could cause a change in the mass and or the charge of the nucleus. So for example, uranium decays into thorium. We can see there it's emitted an alpha particle. When it's emitted that alpha particle, its mass number has gone down by 4, its atomic number has gone down by 2. Because the atomic number determines what the atom is, if we lose protons, we change the atom itself. Now we represent alpha particles in nuclear equations by either 4,2 in the alpha sign there, or a helium nucleus, 4,2 He. Potassium decaying into calcium is different. This is beta decay. We can see the symbol for beta decay, a mass of 0 and atomic number of -1. Again, the mass number of potassium does not change once it's decayed, but its proton number does go up by 1. We'll have a look at that in a bit more detail now. So for alpha decay occurs when a particle containing 2 protons and 2 neutrons are emitted from the nucleus. This changes the makeup of the nucleus. So here's our rule. Write this down. For alpha decay, the atomic number decreases by 2, the mass number decreases by 4. We can represent this in a nuclear decay equation as follows. So if we've got actinium there, 221 and 89, it decays. But the helium nucleus, we need to balance that out, so 221 take away 4 would give us 217. 89 take away 2 would give us 87. We'd look on our periodic table and we find that is francium. Okay, using that rule, could you complete the following alpha decay equations? Please pause the video if you need to, review that previous section and attempt that for us. Pause the video while you do so. Okay, I'll put up on the board the answers to those. In each case, as you'll see, the mass number at the top decreases by 4. The bottom number, the atomic number, decreases by 2. And on each occasion, that changes the atom. It changes the nucleus, so it changes the element. Pause the video while you check through those, and please make any corrections in your green pen. Okay, let's have a look at our second form of decay, beta decay. Now, beta decay occurs when a neutron in the nucleus splits, and when it splits, it forms both a proton and an electron. That electron that's formed is emitted from the nucleus at a really high velocity. It's got lots of energy and flies out, and that is your beta particle. The proton, however, remains within the nucleus. This changes the makeup of the nucleus. Again, write this down as your rule. For beta decay, the atomic number increases by 1. The mass number, however, does not change. We can represent this in a decay equation as we can see below. So you've got there potassium, which has a mass of 40 and an atomic number of 19. Once it decays via beta, one of those neutrons will turn into a proton and an electron. The electron is emitted, but the proton stays where it is. Protons have the same mass as neutrons, so the mass number would not change. But the nucleus now has one more proton than it had before, pushing that atomic number up and changing the element. Again, apply what you've known here to these 5 equations. So go through beta decay, looking at how it can change. Pause the video and restart when you'd like the answers. Okay, here's the answers for this, and again, the pattern is the top number, the mass number, remains exactly the same. It does not change at all. But the atomic number, in this case the bottom number, always increases by 1. You can represent beta decay either with the small e there or with the beta symbol, which is a B with a tail on it. Okay, pause the video and ensure you've got those answers correct. If not, correct them with your green pen. Okay, dangers of radiation. Nuclear radiation is massively dangerous due to ionization. Ionization is where it knocks electrons out of atoms to make them charged. So why is this dangerous to living cells? Pause the video and write down why you think that is. It's dangerous because when atoms in living cells become ionized, one of 3 things usually happen. The cell dies, the cell repairs itself, or the cell mutates incorrectly and then becomes cancerous. We don't want the chances of 2 of those things happening. So when we're exposed to radiation, there is a high chance our cells will either die or the cell will mutate and become cancerous. So if nuclear radiation is dangerous, how can we use it to treat some cancers? We use it to treat some cancers because, as it states on there, sometimes when radiation is absorbed by a living cell, the cell dies. If we can focus it onto cells that are already cancerous, we increase the chance of those cancers dying. So we can focus it on those cells and try and leave the healthy cells alone. Okay, detecting radiation, we've got 2 ways of doing that. First up, using photographic film, and second up, using a GEIGER Muller detector. We'll take you through both of them now. Think where those would be used. So photographic film goes darker when it absorbs radiation. So the more radiation the film is exposed to, the darker it will appear once it's developed. Why can we clearly see the bones of the hand in the X-ray and just faintly see the flesh around the bones? Pause the video and attempt to answer that. Okay, the reason is radioactive particles pass through flesh really easily, so only a small amount gets absorbed. So the film below the flesh gets darker because we get quite a number of radioactive particles hitting that. Radioactive particles get absorbed by bones, so the film beneath them does not get developed. Now again, the more the film is exposed, the darker it will become. Because it's not exposed at all, those areas would be lighter, so it gives us a trace, it gives us an idea of what those bones will look like. Here's a Geiger-Müller tube. The Geiger-Müller tube detects radiation, but how does it do it? So we have our radioactive source, we have this window where it passes through. Inside that metal tube we've got a gas. What do you think that lightning sign means? We've got positive and negative there, and a counter. So think about what the radioactive particles would do to air particles that are trapped in the metal tube. Give yourself a minute, answer the question. Okay, counter needs a closed circuit in order to work or count. So how can the negative and positive terminals be connected for a current to flow through the gas? Well, what happens is the nuclear radiation ionizes the gas inside the tube. That then forms ions, and those ions form a flow of charge. That momentarily flows through the path, completing the circuit and counting the presence of nuclear radiation. So because radiation forms ions from the gas particles inside there, those ions then flow. Any flow of charge is an electric current. That completes the current, counts the nuclear radiation. Okay, quick progress check. Pause the video while you answer those 6 questions. Unpause it when you'd like the answers. Okay, question 1. What's emitted from a nucleus when an alpha particle is formed? That would be 2 protons and 2 neutrons. Question 2. How does emitting an alpha particle change the nucleus of an atom? The mass number decreases by 4 and the atomic number decreases by 2. Question 3. What's emitted from the nucleus when a beta particle is formed? A fast-moving electron is what's emitted. So 4. How does emitting a beta particle change the nucleus of an atom? The mass number remains the same, but the atomic number increases by 1. Question 5. How does photographic film detect radioactive materials? When the radioactive material hits the film, it makes it look darker when it's exposed. And finally, how does a Geiger-Müller tube detect radioactive materials? The radioactive particles ionize gas particles in the tube. These ions flow and that completes the circuit. Every time that circuit's complete, it counts up a radioactive charge. Okay, quick quiz, 4 questions here. Answer for each one is A, B, C or D. Pause the video and attempt to answer those questions. Okay, question 1. Which form of radioactive emission consists of an electromagnetic wave? Alpha, beta or gamma? The answer is gamma. Question 2. An atom has 92 protons and 232 neutrons. After it's emitted an alpha particle, will it have 93 protons and 231 neutrons, 88 protons and 230 neutrons, or 90 protons and 288 neutrons? Well, it's alpha emission. Alpha emission means the proton number goes down by 2, mass number goes down by 4, which gives us C as your answer. Question 3. An atom has got 92 protons, 232 neutrons. After it's emitted a beta particle, what will it have? Will it have 93 protons and 231 neutrons, 93 protons and 232 neutrons, or 90 protons and 288 neutrons? Again, beta radiation means the mass remains the same, but the proton number goes up by 1. So that would be A. 93 protons, 231 neutrons. Neutron number's gone down by 1, protons up by 1. Finally, beta decay involves what? A proton splitting to form a neutron and an electron splitting to form a proton and a neutron, or a neutron splitting to form a proton and an electron. Correct answer would be C. A neutron splits to form a proton and an electron. The electron is emitted at high energy or high speed, the proton remains behind. Okay, hope that was useful for you all. Please review it to go through the answers again, and hope to see you soon. Goodbye.